Hello students, welcome to our student support program for additional mathematics grades 10 and 11. Our topic for today is series and we will be looking at the second part on geometric progression. So let us start. In the previous lesson, we have learned how to recognize a geometric progression, how to find a specific term in a geometric progression, and how to find an expression for Tn in a geometric progression. In today's lesson, we will learn how to find the sum of the first n terms in a geometric progression and how to use the formula for the sum of the first n terms to solve problems involving the geometric progression. So a quick recap on the notations to be used. The first term is denoted by A, the common ratio by R, the number of terms by N, the nth term will be denoted by Tn, and we will have the sum of the first n terms which will be denoted by Sn. Now, let us see how we can derive the formula for Sn. You will remember that T1 is equal to A, T2 is AR, T3 will be AR square, T4 is AR cube, and in general, Tn is AR power n minus 1. So now, S1 means the sum of the first term. That is, S1 will be equal to T1, which is equal to A. S2 is the sum of the first two terms. That is T1 plus T2, which is A plus AR. In the same way, S3 is the sum of the first three terms. That is T1 plus T2 plus T3, which is A plus AR square. Now, in the same way, Sn will be the sum of the first n terms, that is T1 plus T2 plus T3 up to Tn, which will be equal to A plus AR square plus ... up to AR power n minus 1. I call this equation 1. Now, we multiply equation 1 by R. So we will get Sn. Since I multiply equation 1 by R, it means that each term will be multiplied by R. So we will get AR plus AR square plus AR cube plus up to AR power n. And I call this equation 2. Now, equation 1 minus equation 2. So I will have Sn minus Rsn equal to, let us see. We will have equation 1 minus equation 2 and some terms will cancel out. So we will be left with A minus AR power n. Factorizing, I get Sn into 1 minus R equal to A into 1 minus R power n. So Sn will be A into 1 minus R power n divided by 1 minus R. And this is our formula for Sn, the sum of the first n terms in a GP. But remember, R should not be equal to 1 because we cannot divide by 0. If R is 1, then my denominator will be 1 minus 1, which is 0. And division by 0 is not possible. Now, the formula to be used for a GP, Tn will be a r power n minus 1, or we can also say Tn will be the sum of the first n terms minus the sum of the first n minus 1 terms. So we just derived the formula for Sn. However, for convenience, we use Sn equal to a into 1 minus r power n over 1 minus r for r less than 1, and for r greater than 1, we then use a into r power n minus 1 over r minus 1. Let us have a look at the first example. Find the sum of the first 10 terms of the GP 1, 2, 4, and so on. So the GP is 1, 2, 4. What will be the value of A and the value of R? So A will be 1 and R will be 2. I need to find S10. So I will use this formula to find the sum of the first 10 terms since R is greater than 1. Replacing the values, I get S10 equal to 1 into 2 to the power of 10 minus 1 divided by 2 minus 1, which is equal to 1023. Moving on to example 2. Given x, x plus 4, 2x plus 2 are the first three positive terms of a GP. Calculate the sum of the first 6 terms. Let us have a look at the solution. So x, x plus 4 and 2x plus 2 are the first three positive terms of a GP. So my first term here will be x. Now what about the common ratio? So R can be T2 over T1 or T3 over T2, which is what I have done here. So R is x plus 4 over x, which is equal to 2x plus 2 over x plus 4. So I cross multiply, I get x plus 4 to the square equal to x into 2x plus 2. Expanding, I get x squared plus 8x plus 16 equal to 2x squared plus 2x. I send all the terms on one side, I simplify, and I get minus x squared plus 6x plus 16 equal to 0. I divide throughout by minus 1, and I get x squared minus 6x minus 16 equal to 0. I now factorize. I get x minus 8 into x plus 2 equal to 0. So we have two values for x. X can be equal to 8 or x can be equal to negative 2. So when x is 8, I replace into r, which is x plus 4 over x, and I get r to be equal to 3 over 2. So my first term is x, that is a will be 8 and r is 3 over 2. Now when x is equal to negative 2, I replace in r, which is x plus 4 over x, and I get negative 1. But we were told that the first three positive terms of a GP, so we have to consider only positive terms. Therefore, our common ratio cannot be negative, so we reject x equal to negative 2. So we will take r to be 3 over 2 and a to be 8. And I need to calculate the sum of the first 6 terms. So using our formula for Sn and replacing a by 8, r by 3 over 2, we get S6 to be equal to 166 and 1/4. Moving on to example 3. The sum of the first 4 terms of a GP is 40. Its third term exceeds the first term by 8. If the first term is greater than 1, calculate the sum of the first 6 terms. So here, the sum of the first 4 terms is 40. So I will use my formula for Sn. S4 is 40. I replace. I get a into r power 4 minus 1 over r minus 1 equal to 40. Now, we are given the third term exceeds the first term by 8. So I will use my formula for Tn. Third term exceeds the first term, that is T3 minus T1 is equal to 8. I get AR square minus A equal to 8. I factorize, I get A into R square minus 1 equal to 8. And this is my second equation. So we have 2 equations and we need to solve simultaneously. Remember, as I mentioned in the previous lesson, here we are going to use division to cancel one of the unknowns. So equation 1 divided by equation 2. Simplifying, so I will rewrite r power 4 minus 1 as difference of 2 squares. I will get r square minus 1, r square plus 1. So in this case, I have a into r square minus 1 into r square plus 1 divided by r minus 1. Now the division sign will be replaced by the multiplication symbol and we take the reciprocal. So multiply by 1 over a into r square minus 1 equal to 40 over 8, which is 5. We can see that a into r square minus 1 will cancel. We will be left with r square plus 1 over r minus 1 equal to 5. So we continue. We cross multiply, we get r square plus 1 equal to 5 into r minus 1. Expanding the brackets and sending all the terms on one side, we then simplify to get r square minus 5r plus 6 equal to 0. We factorize r minus 2 into r minus 3 equal to 0. So r will be equal to 2 or 3. We now replace, when r equal to 2, we substitute into equation 2, which was a into r square minus 1 equal to 8. I replace r by 2 and I get a equal to 8 over 3. When r equal to 3, I find the value of a, I replace into equation 2 and I get a equal to 1. But I will reject r equal to 3 because here a is 1 and we were told in the question the first term is greater than 1. So we reject r equal to 3. Therefore, r will be equal to 2, a will be equal to 8 over 3 and we need to find S6. So I replace in the formula and I evaluate. So S6 will be equal to 168. Moving on to the fourth example, the sum of the first n terms of a GP is 8 into 2 to the power of n minus 1. Find the first 3 terms. So here is our formula for Sn. Remember, Sn means the sum of the first n terms. So S1, I replace n by 1 and I get 8. I find S2. I replace n by 2 and I get 24. Similarly, S3 will be 56. Now, what is S1? S1 is same as T1. So, I will be having T1 equal to S1, which is 2. Now, to find the second and third terms, I will use the formula Tn equal to Sn minus Sn minus 1. That is, T2 will be S2 minus S1, which is 24 minus 8 equal to 16. And T3 will be S3 minus S2, which is equal to 56 minus 24, which is 32. So the first three terms will be 2, 16 and 32. So here are some exercises for you to practice on the sum of a GP. So students, in today's lesson, we have learned how to find the sum of the first n terms in a geometric progression and how to use the formula for the sum of the first n terms to solve problems involving the geometric progression. So until we meet again, it's goodbye.